Good morning, class. Today we study one-sided limits. So this is a special case of limits wherein we evaluate the limit of a function as x approaches a value a coming from one side only. It could be from values greater than a or from values less than a. Okay, so this will be our topics. So let's start with an illustration. So we want to determine if we have this function f of x. So when x is less than 1, the function is a quadratic. When x is greater than 1, the function is a line. And the graph of this function looks like this. Okay? So yung parabola, ito yung x is less than 1. And then yung uh, line given by this. Okay, ito yung sa line natin. So, as x approaches 1 through values less than 1. So, x is approaching 1. This is the value 1 through values less than 1. So, what value is our function approaching? So, we can see that in the graph, so we will be using this graph. So it is going downwards, and your f of x is approaching the value -2. Okay. So f of x approaches -2. On the other hand, when x approaches 1 through values greater than 1, so now we are approaching 1 from this side, so values greater than 1. So on the graph, we will be using the line. So it is going down, and our function value is approaching this point, which correspond to this value 1. So f of x approaches 1. Okay, so we say that from the left, our function is approaching the value -2, and from the right, it's approaching 1. Now, another example, consider the square root of x. Can x approach 0? So graphically, this is what we have. Okay, this is the graph of the square root of x. So when you say x approaches 0, you need an open interval of values less than 0, so which is demonstrated by this open interval here, and values greater than 0, which is demonstrated by this interval. Okay, so we can see that as we have smaller and smaller intervals, or x is becoming closer and closer to 0, when x is greater than 0, we have points on the graph. Okay. However, when x is less than 0, you don't have any point on the graph here, right? And so no matter how small your interval about 0 is, or how close x is to 0, you cannot find values of x less than 0 for which you have a value for g of x, because then you will have the square root of negative numbers, and that will be an imaginary number. Okay. So we say then that uh, there is no open interval containing 0 such that g of x is defined on that interval. So we cannot let x approach 0 from both sides. However, if we only restrict the values of x greater than 0, then we can say something about the limit of g of x when x gets closer and closer to 0 from the right, okay, or from values of x greater than 0. So this is our intuitive idea. We say that the limit of f of x as x approaches a from the right is L if the values of f gets closer and closer to L as the values of x gets closer and closer to a, but are greater than a. And our notation for this is here. So the limit of f of x as x approaches a, you have the superscript plus there. So we read this as x approaches a from the right of a is L. Take note that when x is approaching a from the right, this implies that our x is greater than a. Okay, so that's the idea. X is approaching a from the right. On the other hand, the limit of f as x approaches a from the left. Okay, so here is a, so your x is approaching a from the left. So on values less than a, so if there is a number that f of x approaches as x approaches a from the left, then that is the limit from the left. Okay, so the limit of f of x as x approaches a, and our notation is the superscript here is a minus. Okay, so x approaches a. Hindi yan negative power class, ha? It's just a symbol, a notation to indicate that our x is less than a. Okay? If the limit as x approaches a from the left is equal to the limit as x approaches a from the right, they are both equal to L, then we conclude that the limit of f of x as x approaches a is L. However, if this limit is not equal, okay, if the limit from the left is not equal to the limit from the right, then we say that the limit does not exist. So, kailangan limit equal pareho. Okay, limit from the left is the same as limit from the right. So, let's go back to our example. So, what is the limit as x approaches 1 from the left? So, when x is approaching 1 from the left, which function do you use? So, x approaches 1 from the left means x must be less than 1. So, the function that we use, the function that we use is this function, okay, because x is less than 1. So we have the limit of 3 minus 5x squared, and it's a polynomial. So you just replace the x by 1, and you get a 3 minus 5 times 1 squared, and the answer is 3 minus 5, which is negative 2. Now, when x is approaching 1 from the right, that means your x is greater than 1. So we are using now this function because x is greater than 1. So we have the limit of 4x minus 3. And replacing x by 1, we get 4 minus 3 equals 1. Okay? So yung negative 2, ito yun. No? Ito yung binibigay niya dito, negative 2. And then yung positive 1, ito yun. Okay, so coming from this direction, ito yung 1. So since these limits are not equal, then we conclude the limit does not exist. Although from the left, the limit is negative 2. From the right, the limit is 1. But the limit as x approaches 1 does not exist. Now let's consider this example. So we have the limit from the right of 0 and the limit from the left of 0. So from the right, so x is greater than 0. So x is positively valued. So we are going in this direction, and we can see that we can replace the x by 0. And that would just be the square root of 0. And the square root of 0 is just 0. Okay? On the other hand, what is the limit as x approaches 0 from the left? So x must be less than 0, so it's a negative number. So coming here in the graph, there is no graph, and the square root of a negative is does not exist. No, it's imaginary. So we say this does not exist. Conclusion: the limit as x approaches 0 does not exist. Okay, although the limit from the right exists, it is equal to 0. Let's look at the Heaviside function. So our boundary is 0. So nagkakatalo tayo sa x is equal to 0. No? So what is the limit as x approaches 0 from the left? So from the left, dito yan, you use x is less than 0. And so x is less than 0 is h of x equals 0. And the limit of 0 is 0. Coming from the right, x is greater than 0. So we use the positive. So h is equal to 1. And the limit of 1 is 1. Okay. So since these two values are not the same, we conclude that the limit of h of x as x approaches 0 does not exist. Now, how about the limit as x approaches 2? Well, as x approaches 2, we only use one function. Okay, eto lang. Kasi 2 is greater than 0. Okay, so even if you have an interval close to 2, it will be greater than 0 still. So you only have one function to use, and that is equals 1, and the limit of 1 is 1. So we conclude that the limit as x of h as x approaches 2 is 1. So now we are particular about the positive or negative values of a radical as it approaches 0. So consider the following. Suppose that n is an even positive integer, and the limit of f of x as x approaches a is a positive number. Then the limit of the nth root of f of x is just the nth root of L. So we discussed this in class. Okay, if the limit of the integrand of the radicand is positive, then the limit of the radical is the radical of the limit. However, if the limit of the radicand is a negative number, we say that the limit does not exist. Okay, and this only happens when n is even. Of course, when n is odd, then the limit of the radical is just the radical of the limit. So question. So what if the limit is 0? So here, we're saying the limit is positive L. We have a conclusion. If the limit is negative, we have a conclusion. But what if the limit is 0? Okay, so what is our conclusion to this case? What will be the limit of the radical as x approaches a? So consider this function, f of x equals 9 minus x squared. As x approaches negative 3, the limit of f of x is 0 because you just have 9 minus negative 3 quantity squared. So that's 9 minus 9 equals 0. As x approaches 3, the limit is also 0. 9 minus 3 squared is 9 minus 9 equals 0. Now, if we factor 9 minus x squared, the factor for 9 minus x squared is 3 minus x and or 3 plus x and 3 minus x. Okay. Now, this will vary in signs. So if you're familiar with the table of signs, so for 3 plus x, the critical number is negative 3. So meaning this becomes 0 at x equals negative 3. What's that? Okay. So yes, I'll put a divider. So this will be positive in sign here and negative in sign there. So meaning if I take a value, say 0, so 3 plus 0 is positive 3. If I take a value here, say negative 4, so 3 plus negative 4 is negative 1, is negative. Okay. And if I have 3 minus x, the critical number for 3 minus x is positive 3. Notice that if I take a value, say 4, 3 minus 4, it's negative. And if I take a value less than 3, it becomes positive. Okay? And you can check for numbers, for 3 plus x, numbers greater than negative 3, the sign of this will be positive. Numbers less than negative 3 will be negative. For 3 minus x, numbers greater than 3 is negative. Numbers less than 3 makes this positive. And if you get the product, so now this is a product that we have. If you take the product, let me put this aside. If you take the product, then you're just getting the product. So negative times positive is negative. Positive times positive is positive. Positive times negative is negative. So from negative 3, so that's from negative 3 here to negative infinity going to the left, it's negative. Okay. And then from negative 3 going to positive 3, it is positive. Okay. So positive. And then from 3 going to plus infinity, it is negative. Okay. And that's what we have here. Okay. Okay. So let me clear this up now. So as x approaches negative 3 from the left, so from the left, that means x is less than negative 3. So we are here. Okay. F of x is approaching 0. But through what values? F of x is approaching 0 through negative values. So this is negative. So approaching 0 pero negative siya. Okay. On the other hand, when x is approaching negative 3 from the right. So this is negative 3. So para bang lagay natin dito negative 3 ito positive 3. So when you approach negative 3 from the right, your function value is approaching 0. But it approaches 0 through positive values. Okay, ito yun, positive. Okay? Okay. Then next is, as x approaches 3 from the left. So ito yung 3 from the left. Okay? So your f of x is approaching 0 through positive values then. Right? However, when your x approaches 3 from the right, so ito na tayo, from the right na approach natin, your f of x is approaching 0 through negative values. So what can we conclude? Suppose that the limit of f of x is 0 as x approaches a. If f of x approaches 0 through positive values, Yung positive muna ang sundan natin. Through positive values, we write f of x is approaching 0 from the right. So 0 super plus. So yan yung ating notation. If f of x approaches 0 through negative values, ito naman yung ating 0. Yung notation natin. F of x approaches 0 super minus. Okay? So notations lang yung ginagawa natin dito. So going back to our example. So here, for this part here, this is f is approaching 0 through negative values. Here, f is approaching 0 through positive values. Here, f is approaching 0 through negative values. Okay, ganun yung nangyayari. Okay? Another example. Consider f of x equals 2 minus x. As x approaches 2 from the left, ano ibig sabihin? X is less than 2, di ba? So, ano yung magiging 2 minus x? So, we can solve for 2 minus x. I just subtract x both sides. So, I get 0 is greater than 2 minus x. So, that means as x approaches 2 from the left, yung 2 minus x natin will approach 0 from the right kasi greater than 0 siya. Okay? So this will approach, so your f will approach 0 through positive values. Okay? You can check, no? Hello, gamitin mo x is equal to 1. So 2 minus 1, positive 1. Or gamitin mo x is equal to 1.9. 2 minus 1.9, positive. On the other hand, if x is approaching 2 from the right, so that means x is greater than 2. So if we derive this expression, we just subtract x both sides. This becomes 2 minus x. So as x approaches 2 from the right, 2 minus x is approaching 0 through negative values kasi 0 is greater. So this is less than 2 minus x is less than 0, and we conclude f of x is approaching 0 through negative values. Now consider g of x. Take note that as x approaches 2, either from the left or from the right, it really doesn't matter, no? Kasi if x is approaching 2 from the left, ang sabi natin kanina, 2 minus x will be greater than 0, but the square will be greater than 0. If x is approaching 2 from the right, we said that this 2 minus x will be less than 0. However, the square will still be greater than 0. Kasi in-square mo yung negative, positive siya. So, in any case, your g of x will be approaching 0 only through positive values. Kasi magiging laging positive yung sign ng g of x natin. Okay, so g of x is approaching 0 only through positive values. Going back to our radical. If n is an even positive integer, if as x approaches a, f of x is approaching 0 through positive values, then the limit of this nth root of f of x is 0. Okay, kasi through positive values, positive numbers yung nasa loob ng radical mo. So defined siya. On the other hand, if f of x approaches 0 through negative values, so yung nasa loob ng radical natin will be negative values going to 0. The nth root of that, n being even, will be undefined. Okay? So the limit does not exist. So papunta siya sa 0, pero through negative values, hindi pwede yun. So, does not exist yung limit natin. So, consider this example. What is the limit as x approaches negative 1 from the left? Now, if you check, if you plug the value, so 2 times negative 1 squared plus negative 1 minus 1. So what you get is 2 minus 1 minus 1, which is 0. So the radicand is approaching 0 as x approaches negative 1 from, as x approaches negative 1. Okay. So now, ang consideration natin is, will it approach 0 through positive values or negative values? Now, parang mahirap i-pinpoint kasi quadratic to, no? Alam nga naman mag-graph pa tayo. So, the idea now is, since nagsi-zero siya, we can factor. So, yung 2x squared plus x minus 1, a factor of that is x plus 1, no? Kasi nagsi-zero siya at negative 1. So, ano na lang yung matitira? Eh di 2x minus 1. Okay, so, yan yung other factor. Okay, you can check that this is correct. Okay. So, when x is approaching negative 1 from the left, this means x is less than negative 1. So, if I want, ito yung nagsi-zero, di ba? Yung x plus 1. So, if I want to derive that from here, I get x plus 1 is less than 0. So, parang nag-transpose lang tayo. So, that means, as x approaches negative 1 from the left, this is always negative. So, ito, lagi siyang negative. Okay? So, tignan natin yung 2x minus 1. So, when x is negative 1, this is simply 2 times negative 1 minus 1. So, this is negative. This is negative 2 minus 1. Negative 2 times minus 1 is negative 3. So, the entire thing is going to positive yung sign niya. No? Kasi magkakaroon ka ng negative times a negative number. Okay? So, the whole thing will be positive. So, this radicand now is going to 0. Okay? So, this radicand is going to 0 through positive values. Okay? So, ibig sabihin, meron siyang limit. Square root kasi siya, and is even, and that limit, clear this up. So, pinactor natin, so negative 3, and then 0 through the left, no? So, sabi natin negative values. Negative, negative is positive. So, approaching 0 through positive values, so, 0 siya. Kasi positive yung radicand mo at any time. However, if you try approaching it from the right, so then your x plus 1 will be greater than, sorry, let me, so your x is greater than negative 1, x plus 1 will be greater than 0. So, ang nangyayari is you get, ito, negative 3 pa rin yan. Tapos, ito will approach, so this will approach 0 through positive values. And negative times positive is approaching 0 through negative values. And that is imaginary. So, conclusion natin, this does not exist. Okay? So, I hope that is clear. No? So, conclusion, what is the limit as x approaches negative 1? Since from the left, there is a limit 0, but from the right, there is no limit. Conclusion natin, there is no limit to this problem. The limit does not exist. Now, in general, we consider one-sided limits for piecewise functions. So when you say piecewise function, it's like we split the function, or the function is split into several functions depending on the interval. For example, when x is less than 0, your function is this rational function. When x is between 0 and 4, your f is this radical. When x is greater than 4, your f is this quadratic. Question, what is the limit as x approaches 4? So when x is approaching 4, we take a look at this 2. So 4 is the boundary. So when x is less than 4, this is the function. When x is greater than 4, the other one, the quadratic, is the function. So when x is less than 4, that is the same as x approaches 4 from the left. So x here is less than 4. So the function that you use is the radical. Okay? Now, take note that this is going to 0. So tignan natin. So if x is less than 4, this implies that 0 is less than 4 minus x. So I just transpose. Dilipat ko sa x sa right side so that I get the form 4 minus x. So this tells us that this is approaching 0 through positive values because it is greater than 0. So this is approaching square root of 0 through positive values. Okay. And conclusion, the limit is 0. On the other hand, if we take the limit as x approaches 4 from the right, so 4 from the right, x is greater than 4. So we use now the quadratic, x squared minus 5x plus 4. And it's just a polynomial, so no problem with this. You just substitute the x by 4, and the answer is 0. So what is our conclusion? As x approaches 4 from the left, the limit is 0. As x approaches 4 from the right, the limit is 0. Conclusion, the limit is 0. Okay? Now, how about when x approaches 0? So, yan yung titignan natin next. Sorry, negative 1 pala muna. So, negative 1. Where is negative 1? In what interval is negative 1? Negative 1 lies here. Okay? So, x is less than, x approaches negative 1 implies that x is less than 0. So, nandito siya sa part na to. No? So, the function that we use is the rational function. And if you replace negative 1, the numerator goes to 0. The denominator goes to 0. So, it's indeterminate in form. So, that means we can use the factor theorem. And we can factor x plus 1. This will cancel. And you just have the limit of x minus 2 as x approaches negative 1. You replace x by negative 1, you get negative 3. And so this limit is negative 3. Okay? So no problem with that. Okay. Now let's consider this problem. Here may reappearance yung absolute value. So firstly, how do you define the absolute value? So the absolute value of t plus 4 is itself if the argument t plus 4 is greater than or equal to 0. If it is less than 0, you just remove the bars and you put a minus sign. Okay? You put a minus sign there. Now, if t plus 4 is greater than 0, this implies t is greater than or equal to negative 4. So we just subtracted 4 both sides. Here, t is less than negative 4. And that will be the new form. Okay? Now, as t approaches negative 4, we have to consider, since our function now becomes a split function, then we have to consider from the left and from the right. So as t approaches -4 from the left, so what function are we using? So we will be using this function because t is less than -4. So you replace the denominator here by this expression, okay? And then we can cancel. So nagsi-zero yung numerator denominator, no? By the way pala, no, at the very start, when you replace t by -4, this goes to 0, this goes to 0. So ito na yon, we can cancel. At matitira sa numerator is 1. So the answer here is 1 over -1, which is -1. If our t is approaching -4 from the right, so it will be greater than -4. This is the function that we use. So we replace the absolute value by t plus 4. And then we can cancel, and we just get the limit of 1, which is 1. And we can see that the limit from the left is not the same as the limit from the right. So we conclude that the limit as t approaches -4 does not exist. Okay. Now, a challenging function is the greatest integer function. I don't know if you have encountered this function. Okay? So, ang sinasabi nito is if our interval, let's start with this. No? Dito tayo mag-start sa 0. If your x is from 0 to 1, so graphic, may graph ba ito? Natin kung wala siyang graph. Okay. So I will try to draw something here. So let's suppose that these are the axes, and our x is 0 to, sorry, 0 to 1. So if x is from 0 to 1, so from here to there, our greatest integer function is 0. So ang magiging graph niya ay, so let me exaggerate this, okay? Pero hindi kasama si 1. So may hole ka ba? If your x is from 1 to 2, here is 2, the value is 1. So this is 1. So from 1 to 2, pero hindi kasama si 2 kasi walang equal doon. Kapag your x is from -1 to 0, your GIF is -1. So -1 is here. So from -1, so kasama si -1 to 0. So may hole. Okay? From -1, from -2 to -1. So do the extension here. Let's just suppose that there's an extension here. So it will be from here to there. From 2 to 3 will be 2 from here to there. So ganyan yung graph niya. Okay? So hindi siya tuloy-tuloy, no? And we can see that the limit as x approaches, for example, 0 does not exist. Kasi from the right, the value is 0. From the left, the value is -1. Okay. Now, saan ginagamit yung GIF, the greatest integer function? Ginagamit yan, class, for example, sa mga tax bracketing. So, Kapag yung income mo, for example, is less than 50,000, ito yung tax mo. Pag greater than 50 but less than, say, 70,000, let's say your tax is 20%. And then higher, your tax is 25%. Higher, your tax is 30%. So, ano yun? Fix yung tax rate on an interval. Pero nagbabago, tumataas. So, that is an application of the greatest integer function. Now, ang sinasabi rin dito is, if I have, let's say, I want to get the GIF of 9.2. Okay? So, the answer here is 9. Kasi, it is the greatest integer less than the value. So, kung saan yung integer na mas maliit sa kanya, na doon mo siya i-equal. So, if I have the GIF of negative 3.5, then the answer here is negative 4. Okay? So, going to the left. So, that's how we apply the GIF. So, what is the limit as x approaches negative 2 from the left of the GIF function? So, once you have set these intervals, then where is negative 2 from the left? Negative 2 from the left means x is less than negative 2. So this GIF will always be negative 3. Okay? And the limit of negative 3 is negative 3. How about as x approaches negative 2 from the right? So negative 2 from the right means x is greater. Okay? X is greater than negative 2. So dito yon. So the GIF is equal to negative 2. And the limit of negative 2 is negative 2. So our conclusion is does not exist siya at negative 2. No? So the limit does not exist at negative 2. Let me just write that. So the limit as x approaches negative 2 of the GIF does not exist. Pero from the left, negative 3. From the right, positive 2. How about 1/2? Ang nasaan yung 1/2? Yung 1/2 is here. Hindi siya boundary point. So dahil hindi siya boundary point, isa lang yung value niya palagi. Whether coming from values less than 1/2, still greater than 0 yon, or values greater than 1/2, still less than 1 yon. So we just have 0 as our GIF function value. And the limit of 0 is 0. Okay. Now, papaano kung complicated na yung ating expression sa loob? So medyo mahirap nang gumawa ng ng table of intervals. So kasi ganito dapat ang mangyayari. So equal siya sa n if n is less than or equal to 2x minus 1, n plus 1. Okay. So tapos i-simplify mo pa yan for the interval x. So magiging, pag tinuloy natin, add 1 both sides, n plus 1, 2x, sorry, magiging n plus 2 ito. So nilipat ko yung minus 1 both sides. I added 1 everywhere. And then I divide by 2, I get n plus 1 over 2 less than x less than n plus 2 over 2. So parang napaka-complicated na ginagawa natin. No? Okay, so yan yun. So ito yung mangyayari. No? So if, parang nakakalito na nga, no? So paano ito? Mas maganda sana pag-usapan to ng face-to-face. Kaya lang, This is a lecture presentation. So this will be the resulting intervals. Okay. Now, how do we evaluate limits? So take note here that when n is equal to 0, so when you set n equals 0, so you replace the n there by 0, that by 0, so you get 1 half and 2 over 2, which is 1. If you make n is equal to 1, you make n equals 1, then this becomes 1 plus 1 over 2, tapos 1 plus 2 over 2. So that would be 1 up to 3 halves. So ito yan. Okay. Pag n is negative 1, so magiging negative 1 plus 1 over 2, negative 1 plus 2 over 2. So this becomes 0 and this becomes 1 half. Okay, so ganun yung nangyayari. So mag-a-assign ka ng value ng n para makuha mo yung interval for x. What is the limit as x approaches 1 half from the left? So from the interval, we can see that ito yung gagamitin natin. The value of the GIF is negative 1. Okay. As x approaches 1 half from the right, ito yung interval na gagamitin natin. The value of the GIF is 0. Paano kung 1/4? So nasaan yung 1/4? Yung 1/4 will be here. Okay? So coming from the left, coming from the right, yung value ng GIF natin is always negative 1 kasi nasa loob ng interval na ito yung 1/4. So negative 1 lang siya. So what is an easier way? So to evaluate limits involving the GIF function, one may do the following. If the limit of the argument inside, whether x approaches a from the right or from the left, is not an integer. Ibig sabihin, pag fraction siya. So the limit of the GIF is just the GIF of the limit. Okay? So, ang mangyayari dyan ay, if this is the case, pag hindi integer yung result, then the limit of the GIF of x as x approaches a, whether from the right or from the left, is equal to the GIF of the limit. Okay? Ganun lang siya. On the other hand, ang problem natin, paano kung integer yung ating argument? So we have two cases. If our function is approaching that integer through positive values or from the right, then, so anong nangyayari, no? Ina-approach niya so f of x, okay, is approaching from the right, no? Parang ganyan, no? So ano ba yung from the right? So ito si n approaching from the right. So ibig sabihin, yung n mo is the greatest integer less than f of x. Kasi f of x here will be greater than n. So, you just replace f of x by n. Kasi diba, ang mangyayari ay titake niya yung integer na less than it. The largest integer less than the value. Okay? So, this is just n. On the other hand, is if f of x is approaching n through negative values or not negative, from the left. So, ang mangyayari is f of x is approaching n through values less than n. So, ibig sabihin, eto si n minus 1, ina-approach ni f of x si n dito So values less than n. So the GIF will be n minus 1. So you replace f of x by the GIF of f of x by n minus 1. Okay? So for example, what is the limit as x approaches 5 from the right of the GIF of negative x over 5? So when x is approaching 5 from the right, so that means x is greater than 5. So that means x over 5 is greater than 1. So negative x over 5 is uh, less than negative 1. Rule on signs. When you multiply by a negative sign, the inequality changes direction when you multiply by negative. So as x approaches 5 from the right, this is approaching the value negative 1. So negative x over 5 is approaching negative 1 through lesser values. So ano yung magiging GIF natin? So this is an integer. So ang GIF natin will be, you replace this by negative 2. Okay? So negative 2 tayo. So let me erase that. Negative 2. So negative 1 minus 1. Yun yung n minus 1 kanina. Sinasabi. How about if x approaches 5 from the left? So x approaches 5 from the left. So x is, so negative x over 5 will now be greater than negative 1. So that means uh, this is approaching negative 1 from the right. Okay? So the GIF will just be replaced by negative 1. And the limit is negative. Okay? How about as x approaches negative 2 from the right? So check muna natin. So ano magiging value niya? Kapag pinalitan mo si x ng negative 2, you get the GIF of negative, o magiging positive 2 over 5 kasi magiging negative of negative 2 over 5, magiging positive 2 over 5, the GIF of this is just 0 kasi hindi naman siya integer. Okay? So this is just 0. So it's the number integer closer to 2/5 is 0. Okay? I hope that this is clear. So one more example. As x approaches negative 1/3 from the right. So paano natin gagawin to? So x is approaching negative 1/3 from the right tells us that x must be greater than negative 1/3. No? Okay. So if I multiply by 3, I get 3x is greater than negative 1. So multiplying by a positive will not change the inequality. And then I transpose so 3x minus 1 will be greater, not transpose. I am getting 3x minus 1 will be negative 1 minus 1, which is negative 2. So 3x minus 1 is greater than negative 2. So as x approaches negative 1/3, 3x minus 1 is approaching negative 2 through positive values. Okay? So we can just replace this by the GIF of 3x minus 1 will just be equal to negative 2. How about as x approaches 2 from the left? So, ang sabi natin kanina, diba? 3x minus 1. Pag pinalitan muna natin siya ng 2, so magiging ano siya? So, magiging 3 times 2 minus 1, which is equal to 5. Okay? So, approaching 5 ba siya from the left or from the right? So, if x is approaching 2 from the left, so ito yung 2, x is approaching 2 from the left, so actually you can try values, no? Will this be greater than 5 or less than 5? So let's say you try 1 na lang. So 3 times 1 is 3 minus 1 is 2. So less than 5. No? So this is approaching 5 through negative values. Okay. And so we take, so ito si 5. So yung GIF niya will be yung 4. Okay, and the answer is 4. How about 3 halves? So if you replace the x by 3 halves, what we get is 3 times 3 halves minus 1. This is 9 halves minus 1. This is 7 halves. And 7 halves is 3.5. So the GIF is 3. It's just 3. Kasi fraction naman siya. Okay? All right, so here are exercises for you to practice on. And also another exercise. Okay, medyo challenging exercise. Okay, so that ends our lecture video on one-sided limits. I hope that you, aside from listening to this lecture video, you also read the book for references and more examples. Okay, so that is all. I'll see you on next week.